So today I'm going to show you some strategies of how to solve a linear system using elimination. So substitution and elimination, they get you the same result. They get the solution x comma y to a system of equations algebraically. Elimination, when a problem is set up such that the x's and the y's and the constants are on top of each other, it is perfectly set up for elimination. When you have one of the variables that is already isolated, like x equals 5 plus y, you're ready to do substitution. So I'm not going to require that you have to do substitution or elimination. You'll just have to be able to use one of them to solve a problem and show the algebra steps. So just guessing x comma y is not going to earn you full credit. So here are the steps you're going to take. You're going to line up your equations. You might have to multiply the equations through by a constant. And then you're going to do kind of the same steps. You're going to solve for the variable, plug it back in, and solve for the other variable. So here's our first system of equations. And if you notice, the x's, the y's, the equal sign, and the constants are already lined up on top of each other. And when you add the two equations together, 2x and negative 2x adds up to 0, and the x variables will eliminate. So this first example, you're ready to do elimination. And if you were going to actually do substitution, you'd be making more work for yourself because this is definitely set up to do elimination. So I'm going to cross out my 2x's because 2x plus negative 2x adds up to 0. I'm going to add my y's together, so I get 7y equals negative 14 because I'm going to add negative 4 plus negative 10. Now I'm ready to solve for y. So I'm going to divide by 7 on both sides, and I get that y equals negative 2. So my next step is I'm going to plug this negative 2 either into the top equation or the bottom equation to solve for x. So I'm going to go ahead and plug it into the top equation. So I would have 2x plus 3 times negative 2 equals negative 4. So I've replaced this y with the value negative 2. So now I have 2x minus 6 equals negative 4. Add 6 to both sides. 2x equals 2. And last step, divide by 2. Voila, I know that x equals 1. And I should write the answer to this system of equations as a coordinate. So 1 comma negative 2 is my solution. If I plugged them back in, I should get true statements. So if I plug in 1, 2 times 1 is 2, 3 times negative 2 is negative 6, 2 minus 6 is negative 4. If I plug in the coordinate into the other equation, I would get negative 2 plus negative 8 does equal negative 10. So always check that your solution works. All right, so in example 2, my x's are lined up, my y's are lined up, my equal sign and my constant. But when I add these together, I'm going to get either 5x or 7y. So I will not eliminate one of my variables. So you have to decide to either eliminate your x's or eliminate your y's, and we're going to multiply one of our equations by a constant. I'm going to choose to eliminate my x's. So I'm going to multiply my top equation through by negative 4. See how I'm going to get negative 4x here and positive 4x here? If I wanted to get rid of my y's, what would I have to multiply by? I would multiply the top equation through by negative 6 instead. But I'm going to do negative 4, like I said. So I'm going to multiply that whole equation through by negative 4. So I would get negative 4x minus 4y equals negative 16. So multiplied by negative 4, multiplied by negative 4, multiplied by negative 4. The bottom equation I'm going to keep exactly the same. So 4x plus 6y equals 10. So now I'm back at the same point where I stopped, or where I started this process over here. So I can add together the equations because my x's eliminate. I get positive 2y equals negative 6 when I add them together. divide through by 2, and I get y equals -3. Once I have y, I can plug it into either the top equation, the bottom equation, or my new equation over here. I think the easiest place is this top equation. X plus y, -3, has to equal +4. So just by adding 3 to the other side, I can see that x would have to be +7. So my final answer is 7, -3. Remember, your x always goes before your y, so make sure to write them in the correct order. Okay, so my next example, I've got my x's lined up, my y's lined up, my constant and equal sign lined up, but there's nothing that I can just multiply one of the equations by. So the hint is I'm going to need to multiply both of my equations by a constant. So if I wanted to eliminate my x's, I could multiply the top equation by 3, so that would give me 6x, and the bottom equation by -2, because that would give me -6x. If I want to eliminate my y's, I could multiply the top equation times 2 and get 10y. I can multiply the bottom equation by 5 and get -10y. So because there's a positive here and a negative here, I'm going to go ahead, I'm going to multiply the top equation by 2 and the bottom equation by 5 and eliminate my y's. So my equation is going to be 2 times 2x is 4x, 2 times 5y is 10y, 2 times 20 is 40. My bottom equation will be 15x minus 10y equals -40. 40 minus 40 is 0. 10y minus 10y is 0, and I get 19x on this side. If 19x is 0, when I divide by 19 on both sides, x has to be 0. X is allowed to be 0, right? So now I'm going to take my 0 and I'm going to plug it into any of the equations for x. So that would give me 5y has to equal 20 if I plug it in for here. So if 5y is 20, then y would have to be 4. So 0, 4 would be my solution. Let's just double check. 0 here, 4 here would give me -8, -8. So that checks out. So that's a case when you have to multiply each equation through by a different constant. All right, and then on example 4 here, if you notice that I don't start out with a lined up equation, but if I try to do substitution, dividing by 2 is not a good option right here. So it doesn't take me any more time to just add the y back to the left-hand side of the equation. So if I add y, I'll have 2x plus y equals -4, -4x minus 3y equals 10. So let's see, when I add, I can't add them together yet, right? I'm trying to get them to eliminate. So I'm going to multiply my top equation through by a constant that's going to help me eliminate my x's. Can you figure out what I'm going to multiply by? I'm going to multiply by 2. So I'm going to multiply the top row through by 2. I'm just going to write it underneath here. So I've got 4x plus 2y equals -8. So now I'm ready to add these bottom two equations together, right? My x's are gone. I get -y or -1y equals 2. Divide by -1, y equals -2. So if y equals -2, I can plug that in anywhere, here, here. I'm going to plug it in this top equation. I tend to just use the top equation a lot of times. So 2x equals -2 minus 4. And we know that a double negative just means a positive. So I really have that 2x equals -2. So x would have to be -1. So -1, -2 is the solution for that problem. And I could check it, might as well check it in this bottom equation here. But if I plug in -1 here, I would get +4. If I plug in -2 here, I'd get +6, and 4 plus 6 is 10. So hopefully that was a good taste of elimination. I'd like you to try just 2 problems using elimination yourself. Take your time, show your steps, and that way I'll know what you did right or wrong. And then on number 7, you're setting up an application problem about money. Feel free to look at your notes from day 6 on substitution applications. Feel free to use substitution or elimination to get your solution. And you're just sending me a picture of this page so I can give you some feedback. Thanks.